You know, every programmer hits that wall eventually. That pivotal moment when you realize you absolutely have to master C structures and pointers if you want to get serious about your craft. Well, welcome to today's explainer. We're going to take those seemingly abstract syllabus concepts and transform them into practical power tools for incredibly efficient data management. We're pulling directly from the core computer science material to demystify what are, honestly, some of the most intimidating elements of C. But hey, before we get completely lost in the technical weeds, let's look at the real-world chaos we're actually trying to solve here. Picture this for a second. You've just been tasked with managing thousands of student records for a massive university. You've got to track names, roll numbers, grades, percentages, the whole shebang. If you try to tackle this with just basic programming knowledge, you are going to hit a wall of disorganized data so fast. And worse, you might literally crash your system's memory. So, how do you actually handle it? Okay, let's dive right in. The old, chaotic way of doing this, it involves declaring dozens, maybe even hundreds of separate variables. You know, student1 underscore name, student1 underscore roll no, student1 underscore marks. Actually, scratch that. It's a total nightmare to maintain. But the efficient way, that is our very first tool, the C structure. It elegantly packs all those related details into one clean, easily manageable unit. Section 1. Organizing chaos with structures. Your digital filing cabinet. Take a look at Task 10 from our source syllabus. It specifically asks us to define a structure for student information. We're talking roll number, name, marks, percentage, and grade. A structure is brilliant because it lets us take totally different data types, like strings for a name and floats for a percentage, and group them securely inside one single digital ID card. It's elegant, it's clean, and it just completely removes the clutter. And look, this isn't just about making your code look pretty for your professor. As our source material points out in Learning Objective 5.1, mastering this allows you to store, access, and manage student records efficiently. More broadly, the syllabus explicitly connects this fundamental programming skill to promoting lifelong learning, which ties directly into Sustainable Development Goal 4. By structuring data properly, you're building a foundational problem-solving skill that translates way, way beyond just C programming. Moving on to Section 2, Mastering the Pointer, Navigating Data like a Pro. So here's the catch. Structures alone have a limitation. Passing massive structures around your program eats up memory incredibly fast. Enter the pointer. A pointer is simply a variable that stores the memory address of another variable rather than the actual data itself. Think of it this way. If a structure is a massive house full of heavy furniture, a pointer isn't a copy of that house. It's just the GPS coordinates. It's a treasure map. Instead of dragging heavy data around all over the place, you're just telling your program exactly where to look for it. And wow, do pointers unlock a massive toolkit. The syllabus outlines this huge, expansive set of capabilities. We're talking the address operator, pointer variables, pointer arithmetic, pointers to pointers, passing arrays to functions, dealing with 2D arrays. I know, it sounds like a recipe for a segmentation fault. But the ultimate tool here is dynamic memory allocation. This means your program can literally ask the computer for more memory on the fly as it runs. It is unbelievably powerful. All right, Section 3, Pointers Meeting Structures, the ultimate crossover. So what happens when we smash these two concepts together? This brings us straight into Task 11 of our syllabus, which challenges you to use pointers to directly access and modify structure members of a student record. This dynamic synergy right here, this is where you level up from a beginner to an advanced programmer. You aren't just holding data anymore, you are surgically interacting with it. This crossover is an absolute game changer. Copying entire structures is slow, it's clunky, and it completely hogs memory because you duplicate all the names, grades, and percentages every single time you want to make a tiny change. But pointing to structures, that is fast, it's light, and it's efficient, allowing for direct modifications to the original file. As Learning Objective 5.2 points out, applying this combination enhances your programming proficiency and your problem-solving speed immensely. Which brings us to Section 4, Building the Ultimate Application, Defeating the Final Boss. It is time to put it all together to defeat the final boss of the syllabus. Task 12. We are tasked with developing a menu-driven, fully integrated application. Step 1 involves getting the data in and viewing it, record entry, and display. Step 2 allows for dynamic interaction, so searching for specific roll numbers and updating their files. And Step 3 is where it gets really smart, calculating the highest grades for topper identification and generating the full results.
To actually pull this off, you need an architecture that uses everything we've talked about today. You use structures to lay out the data logically, you use arrays to hold multiple student records, you use functions to handle the different menu actions cleanly, and finally, you use pointers to ensure that searching and updating are lightning fast and memory efficient. This perfectly fulfills Learning Objective 5.3, proving that you can absolutely synthesize these individual concepts to solve real-world student data management problems, all while practicing professional-grade programming.
You've completely upgraded your toolkit. From basic variable declarations to engineering a fully optimized data management system, you now have the power tools to build highly efficient C applications. Structures give you the organization. Pointers give you the speed and precision. So as we wrap up this explainer, I want to leave you with a bit of a challenge. Armed with this brand new understanding, what real-world data problem will you solve next? Keep building, keep exploring, and hey, thank you so much for joining me on this deep dive.